the end here, this is where these are what we call product forwarding pumps. So this is taking the product out of those tanks and sending it up the hill to the WAPA tanks and then WAPA distribution takes it from there and distributes it out to the rest of the distribution system and out to the people. So that's the 3 flow meters that the water's flowing through, and we're pumping the water up the hill with these pumps. So this here is the reverse osmosis unit. Hey guys, there's three units that run in parallel here. So each we can run 1, 2, or 3 of them at a time. Right now, today we're just running 1 down there at the end. So these 2 are not functioning. These are the 2 that you can browse around and look at. The process, the membrane reverse osmosis process runs on pressure. It's a pressure-driven process where high-pressure water is being driven through the membranes. This pump here is the high-pressure pump. This is really the big consumer of energy, and this is the high pressure. This is what creates the high pressure to put it through the membranes. So this is really where 90% of the energy that we use in this plant is using this pump. So we take this pipe here is bringing this filtered seawater into this pump, and it's pumping it up through the stainless steel pipe and into the vessels, into the pressure vessels. Each one of these pressure vessels has 7 membrane elements, and each one of those membrane elements will allow the fresh water to permeate through and collect it into a collection header and then deliver it to that tank. And that's really all there is to it. I mean, reverse osmosis is a simple process in many ways. It really the only requirement is that you have clean, highly filtered water that you bring into the high pressure pump into the membranes, and then you pressurize that clean, highly filtered water, and then the membrane really is what does the work. It lets the fresh water permeate through, keeps the salt on what we call the concentrate side of the membrane, and then we discharge that as waste. So so we have 3 units the same here, and maybe if you'd like to take some time, you can look around. There's a little bit more to it, and this will be a little bit of advanced reverse osmosis for the engineering types. But we have our waste stream is highly pressurized, but it's high salinity, and so we've invested all this energy into pressurizing the salt water, and those yellow units are what we call pressure exchangers, and those will recover some of that energy that we've invested in high pressure, high salinity water, and use that energy to pump low salinity water. So they're energy exchangers and energy recovery system. So a lot of the complexity that you see around the system is in energy recovery with those yellow units, whereas the process of actually making fresh water out of seawater using the membranes is really pretty simple. Pressurized on one side of the membrane, the fresh water goes through, the salty water stays behind. So a lot of the complexity that you see has to do with recovering the energy. So this is 1 RO unit. This makes 1.1 million gallons a day. We have 1, 2, 3 of those online here, so we can make 3.3 million gallons a day of water here. If we go down and around so we don't have to walk through the operating part, you can see there's a big empty space that we've got full of pallets of stuff. But that is space, and we've got all the headers ready for a 4 train. So we're ready for 4.4 million gallons a day of water, which should serve the needs of the territory of St. Thomas and St. John for the next 20 years.
Right now we have a demand of about 1.8 million gallons per day. So we have almost double the need right now being met here. So we have room for growth. We can add on industrial customers, we can add on more customers, we can expand the system, and even if the 4 train can come in, we can meet the needs of the territory for many years.
cyclone rated. So this is the final filtration before the water goes to the RO unit. So now we've got water coming through the sand filter, now through these cartridge string filters, and now it goes into a header bed and ready to go to that RO unit. It's that low pressure